Hey guys, Algebra 2, welcome back to another super exciting video of math. Mr. A, you guys, I'm excited to see you. It's a beautiful Monday morning over here in the very quiet classroom of Mr. A's room. But hey, I still miss you guys. It's never going to quite be the same. So just doing everything I can to make sure we make a little bit of the classroom come to you. So today we're looking at section 2, chapter 11. We're going to be talking about theoretical and experimental probability. Theoretical probability, the quick way to describe it there is just there's always a specific number of odds for something that can happen. The theoretical is just doing the math behind it. So in other words, if you're going to be flipping a coin, there's two sides. You always technically have a 50-50 chance of getting that heads or that tails. But the experimental is you actually conducting it. Do the real experiment. And the random hypothetical, you flip that coin 10 times, you should land on heads 5 and tails 5. But that might not happen. What if you land on heads 8 of the 10 times? Then that would be your experimental because you actually did it. All right, so that's just a quick run through. You guys need to copy the 8 key terms from this section and the 3 key equations. All right, I'm going to move off to the side, pause the video if you need to, copy all this stuff down. That way we can flow through our examples. All this stuff that you're looking at right here, this all relates to examples that we're going to be dealing with. So when we get to 1A, 1B, 1C, we're going to be looking at this chart of the red and blue number cube on page 803. So a note off to the side is you really need to be following along in your textbook with these videos, for these videos to make sense, for you to actually grasp the material. So make sure that you guys are having your textbook open right now. Okay, so let's take a look at example 1A. And page 803. So we're looking at that chart at the top of page 803. That chart right there gives you all the possible outcomes for a red number cube and a blue number cube. And what we got here for 1A is the sum is 6. All right, so sum meaning addition. The sum is 6. Got my little cheat sheet here, making sure I give you guys the proper info. So basically what we're looking at is it is what you want divided by the total number of possibilities, okay? So what we want here is a sum of 6 over 36 total possibilities. Imagine you got one number cube, there's always 6 sides. You got a second number cube, 6 sides, 6 times 6, there's our 36. All right, if you guys use that chart, you're gonna see these are all the different possible combos that can equal a sum of 6. So right there, if you use your chart, these are the 5 that are going to be equaling a sum of 6. So that's going to tell us that we have a 5 out of 36 total. That will be what we want, which was a sum of 6. 1 plus 5, 5 plus 1, 2 plus 4, 3 and 3, 4 and 2. All of those right there are going to give you a sum of 5 out of that total 36. All right, that was 1A. Let's take a look at 1B. 1B is going to go fast. The difference is 6. Difference meaning subtraction, and the answer is 6. Now just use a little bit of logic here. If we are subtracting and the biggest number is 6, and on a number cube there is no 0 as a number, then for 1B, our answer is 0. There is no combination on that entire number chart of 36 combinations where if you subtract any of those numbers that you will get an answer of positive 6. All right, so that was for 1B. Let's take a look at 1C. All right, the question here says the red cube is greater. All right, so if again you are referencing the textbook here and you look at that chart at the top of the page that gives you every possible outcome, all 36, again, our denominator is 36. That's the total. Now you need to look at that chart and figure out, what do you want? You want the red cube to be bigger than the blue cube. So just use that chart, count it out. How many times in that chart is red bigger than blue? When you count it out, you're going to get 15 different combinations where red is greater than blue. Reduce that down, and you're looking at 5/12. For probabilities, always reduce. If the fraction can reduce, you must reduce the fraction. All right, we're going to clear out some space here. That way we can take a look at number 2. All right, so number 2 here. We have two integers from 1 to 10 are randomly selected. All right, so integers from 1 to 10 are randomly selected. We know right there that we have a 10 in our denominator because we have 10 possible numbers. All right, back to the question. Two integers are randomly selected. The same number may be chosen twice. So the fact that the same number can be chosen twice means all possible outcomes are always on the table. You're not taking away a number once you pick it. You could pick the same number again and again. All right. And we are asking, what is the probability that both numbers are less than 9? So I'm going to put a P for probability, and we're saying both less than 9. All right, so what we have here is we are getting how many numbers total? 10. Of those numbers, how many are less than 9? 8 of them. 1, 2, 3, 4, 5, 6, 7, 8 are all less than 9. So 8/10, that becomes the magic fraction here. And again, a number could be repeated. That's what they told us in that first sentence there. So you have 8 out of 10 for one of those numbers. You have another 8 out of 10 for the other possible number. So what we're doing here is we are multiplying these two fractions together, which really, when we reduce it, it's 4/5 times 4/5 equaling 16/25 for our number 2. Okay, again, what they told us is you have two integers from 1 to 10. 10 is our total. We're picking 2. The numbers can repeat. That's why these fractions are allowed to be the same, and they both need to be less than 9. There's 8 possible numbers less than 9, and we're picking 2 of them. Multiply it together to get the overall total probability of both numbers being less than 9. All right, so that's number 2. Okay, let's take a look at number 3. Okay, number 3, turn the page, 804. We're trying to determine, by the way, on number 3, if we're using a permutation or a combination. So you got to look back at section 1, do a little review if you forgot what the permutation or combination was, because we're going to be doing one of those. If you can look back at section 1 and make sure you understand also how to use the calculator, it's just going to save you time. It's not like it's the only way to do it. Algebraic method always works. But the calculator method, if you know how to do it, will save you a lot of time. All right. So number 3, a DJ randomly selects 2 of 8 ads. Right there, the word randomly means that order doesn't matter here, okay? So what we are doing is a combination Okay. And so let's see, we have 2 of 8 adds. You guys remember, the bigger number always goes in front, 2 smaller number goes second. Now, then they want, what's the probability that both of these adds will come from the same retailer? Okay, so when you do the math here and figure that out, you are going to get 28. Okay, so again, look back at section 1 if you need the review on the permutation and the combination. But we know that this is a combination. That word randomly kind of cues you into that. And once you determine that there's 28, we're not done yet, because what they're asking is, what is the probability that of these 28, that one retailer will actually be it? There's only one favorable outcome. So this is actually going to be a probability of 1 over 28. There's 28 different combinations of these commercials being presented to the listeners, and what number of those combinations will give you a true favorable outcome? Only one, because the one retailer that has 2 ads, for both of his 2 ads to be presented, there's only a 1 in 28 chance of that actually occurring. Okay, so that was number 3. Let's move on to number 4. I'll leave this one up there. Okay, number 4 deals with a little bit of geometry. Trust me, not difficult geometry. All right, we got a triangle. We got a smaller triangle right at the top. The little triangle is a 4 by 4. The big triangle is a 15 by 15. Now what they ask is, what's the probability that a point chosen at random is inside the large triangle and that it's also inside the small triangle? So in other words, if someone were to pick a point anywhere on this triangle, somehow it's going to be in the small, which is also within the big. So again, what you're looking for is just what you want over the total. All right, well, the total is the whole triangle, the full triangle. So if you do the math behind that, you're just going to have the total triangle is 225, and the smaller triangle is 16. And so right there, that's it. All right, you have a 16 out of 225 chances of getting one dot in the small that's also within the big. Okay, so 16 out of 225. That was for number 4. And last problem here, let's clear out some space. We're going to do number 5, part B. All right, number 5, part B. Okay, what you're going to need to be is on page 805, and at the bottom of that page there's a little chart that talks about the experimental, so that means they actually did the experiment. That's where these numbers are coming from. And it's all about different cards being picked. So you should see hearts got 5, diamonds got 9, clubs got 7, and spades got 5. The question says find the experimental probability of choosing a card that is not a club. All right, well, how many total were picked? The total is 26. How do you get that? By adding all those numbers together. 5, 9, 7, and 5. Then find the experimental probability of choosing a card that is not a club. Not a club, well, that's going to be 5, 9, and another 5 for a grand total of 19 out of 26. Okay, so these are the cards that are not a club, and the total number of cards that were picked was your 26. So So that's how we get the 19 over 26. All right, guys, that basically sums up section 2. Again, there's a lot of conceptual stuff here. You need to understand the words that are being given to you often mean something important. So the word random means something important. Words like not replaced or replaced, when you hear those words, especially in the next section, those are very important, okay? I'm going to move off to the side here, finish copying stuff down, rewind these videos, watch them again and again. If you got questions, email or personal message, and that should cover it. All right, love you guys, miss you guys. I'll see you in the next video.